Hello, I'm going to show you guys how I make water molecules to be used in a LAMP molecular dynamics simulation. The four basic steps that I use in order to accomplish this are to get a box size estimate, then from there I can generate water molecule coordinates with PacMol, then I can generate the water molecule file, then I can test that water molecule file. So let me head over to MATLAB. Let me start sharing that. Just make sure you all can actually see my MATLAB screen. So I'm going to make water molecules in the SPCE type, which stands for Simple Point Charge Extended. I'm going to create 40,500 water molecules, which can be seen right here. I've got the molecular weight of a water molecule, Avogadro's number, and different densities based upon the temperature and pressure that I'm looking at. The temperature and pressure that I'm going to be concerned with this simulation is water at 1 atmosphere and 100 degrees Celsius. So let me run this right now in this section. From there, I should have generated a approximate size of the cube of water, of how large the simulation domain should be and the edge length. I'm assuming that the domain I'm looking at is a perfect cube, so each cube length is each side of the cube has the same exact length. So I just need to find the cube root of the volume that I have, and it spits it out right here in angstroms, which is approximately 108.1288 angstroms. So with that information, I can now go over and create a PacMol script file. So let me share that. Good, you all can see that now. So what I'm going to do right now is I'm just going to walk through kind of the steps of the script file, what it looks like. All right, I have the tolerance of the between water molecules of 2 angstroms. So I want to make sure there are no water molecules that are at least 2 angstroms apart from each other. This is the file type that I'm going to output the export file into. And this right here is the name of the file. So it's going to be called liquid water SPCE 40,500. So I can be able to tell what it is. And then I need to read a structure file, which is out the way. The SPCE water to XYZ structure file, and that gives me what the spacing between each water molecule should be. So it's going to give me the correct angle and bond length that each SPCE water molecule should have. Then I'm going to create 40,500 water molecules, and I'm going to put them inside the box that I just defined right here. Then I'm going to end the structure. So then from here, this is all the information I need in order to run the PacMol software, which once it's done running, it's going to spit out this file right here, which looks like this. And now I have the coordinates of each atom in the simulation. So with that information, I can go back over to MATLAB. And now I'm going to open up a different file. Actually, let me just clear this out. Let me go over to here. I just need to put in the number of water molecules I have and the file that I'm reading. And now I can simply just run this. Let's go. Now I have all the data that I need. And the data is going to be in 3 distinct tables. It's going to be an atom table, bond table, and angle table. Now with these 3 tables, what I would physically do is highlight it, copy it, and then paste it over into a water file, which is going to look like this. To denote the total number of atoms, bonds, angles, atom types, bond types, and angle types, size of simulation domain, masses of each molecule in a water, each atom in a water molecule, the bond coefficients, the angle coefficients, and then I would paste the information under each of these headings. The atom heading, the atom table goes underneath that. If I just need to pull this down. And paste the bond information underneath this bond heading. Then paste the angle information under this angle heading. So that'll create, so that right there, after I've done pasting all the information in, now I have a water file that LAMPS can actually read. In order to test that everything's going to work out, I put in an example script file that I have where I can just read it in from here. Yeah, the name of the file right here. Run it for a short amount of time than I normally would, so run down for 6 time steps down there, 1 up here, another 1, 0. Just run 1 right here. So I'm just going to run it for a total of 7 time steps. Going to make sure that I can actually get through the simulation without a crash, and once I'm good with that, then I can send it off to the supercomputer. So that's the process I need to do in order to create water molecules for each different simulation run that I want to do. So you can see that once we have the Python script that can automate this, but hopefully it's a press of a single button, that's going to take this time down from approximately 5 minutes to, well, approximately from the troubleshooting, if I am correct with it, if it takes it down from 15-20 minutes of doing this down to a minute or a couple seconds once I have an idea what I want to do. So yes, that is the tutorial on how I create water molecules for a lab simulation.